The second property of transition metals is formation of complex ions. Now, complex ions is combination of a transition metal ion that is surrounded by ligands. Now, ligands should be defined as neutral molecules or anions with lone pair or non-bonding pair of electrons. Example, water is a ligand, ammonia is a ligand, hydroxide has lone pair on oxygen ligand, cyanide, and chloride. They are also referred to as Lewis bases. So a ligand is a Lewis base. It has an electron pair to donate. Now, going back to the transition metal, is highly charged, very positive, very small, has partially filled the orbitals. Therefore, it can attract electrons from ligands, and it forms a new covalent bond known as coordinate covalent. It's not a normal covalent, it's coordinate because it has both electrons belonging to one species only. If you look at the example, when you take copper sulfate and you add it to water, it's going to be surrounded by, the copper ion is going to be surrounded by H2O molecules, 6 of them. And this is known as a complex ion, and it's actually blue. And if we open it, the copper is going to be forming a coordinate covalent bond with oxygen of H2O. Another one down here. And then you have 4 corners, a square here. Now the shape, every time you have 6 attachments, you are octahedral. So it has a shape, it has a color, and it's a complex ion. We put it in a bracket, put the charge, 2+, and it's blue. This is a complex ion, which is a transition metal with surrounded by ligands. And this arrow, the one-sided arrow, remember this is coordinate covalent. Coordinate covalent. Now we can swap the ligands with something else. So what happens if I add ammonia to this plus ammonia in form of ammonium hydroxide, there is an equilibrium. It will shift to the right and it will give you Cu, 2 H2Os, and 4 ammonias, 2+, and the color changes simply into deep blue. So we can swap ligands, and the shape is H2O. I'm not going to open the structure anymore, don't have enough room. And then you have ammonias. Then again, this is surrounded by 6 ligands. So the shape is 2+, means the shape is octahedral. And this is deep blue. You really don't need to know that much of colors, but it's good to appreciate some. Now what happens if I add this copper surrounded by water to hydrochloric acid? It will change into yellow, and it will give you a new complex, Cu, Cl4, 2-, and we are going to talk about all these numbers, how they change, because the ligand here has chloride, which is 1-. The shape is either tetrahedral or square planar. So chlorides are forming coordinate covalent, and this is 1, 2, 3, 4 coordination number, 2-, and this is yellow, and this is square planar. So the second property is that transition metals form complex ions, which is combination of the metal ions surrounded by ligands. Ligands should be defined as neutral molecules or anions with lone pair or non-bonding pair of electrons. And this bond here is not a normal covalent, it's coordinate covalent. One final note this here, we have monodentate ligands, which are what we just saw, water. They only have one lone pair of electrons to donate information of complex ions. We also can have a polydentate, which has more than one lone pair of electrons. Ethylene diamine, for example, is NH2, CH2, CH2, NH2, and each of the nitrogens has a lone pair of electrons to show. So sometimes we show it as NH2 lone pair, and then instead of CH2 we just show this junction, another CH2 and H2. So if you look at the cobalt complex, for example, this structure, this is this double dentate ligand